Hello everyone, welcome to my YouTube channel MS Education. This is my first video on YouTube. If you like my video, then subscribe my channel to get notification. Today I will solve class 6 mathematics exercise 3.1. So let's start. So here is exercise. Exercise 3.1. Number 1 question. The question is, write all the factors of the following. So number 1 is 68. So here the question is all the factors of the following. That means we have to find out the factors of 68. So to find out the factors of any number, we have to go through the factorization method. Actually this is the easiest method, otherwise you have to check one by one. So if we go through the factorization method, then we have to first find out this number is divisible by which number. We have to divide the smaller number. The number is divisible by 2 as the number ending with 8. That means this number is even numbers. As we know, the numbers ending with 0, 2, 4, 6 are even numbers which are divisible by 2. So this number is divisible by 2, then 2 3 is 6, 2 4 is 8. And again this number is even numbers, that means this number also is divisible by 2. 2 1s are 2, 2 7s are 14. And then as 17 is the prime numbers, that means this number is not divisible by any other numbers. So this number will remain the same, and you can say that 17 1s are 17. So here we the numbers we get, that is 1. As we know that 1 is the factors of any number. So 1, then the number is 2, then 3, there is 3, or even if we multiply any two numbers or three numbers, then we will get 3. No, then 3 will not be the factor of 68. Then we go to 4, 2 to the 4, then 4 is the factor of 68. Then 17, then 17 to the 34, then 17 to 34, 34 to the 68. Even we can conclude from there that these are the also factors of that number. So we can say that 1 2 4 17 34 and 68, these numbers are the factors of 68. And if the question was like that, how many factors of the number 68, then we can say that 1 2 3 4 1 2 3 4 5 6, 6 numbers are the factors of 68. So the next question is 72. So we have to go through the factorization method. 72, this number is also an even number, that the number is ending with 2. 2 3 is 6, then 12, 2 6 is 12, 2 1 is 2, then 2 8 is 16, then 2 9 is 18, 3 3 is. So from here we can consider 1 is the factor of 72, and then we can say also that 3 1s are 3. 1, then we got 2, 2 2s are 4, 4, then 5. There will not, actually the number will be 5. Factor the factor 5 will not be the factor of 72, as there is not any possibility to get 5. Then we go to the 6, 3 to the 6, then 2 to the 4, 4 to the 8, then there is 9, then 10 11, no possibility to get 11. Then we go to 12, 3 to the 6, 6 to the 12, then 12 is also the factor of 72. Then 18 is also for 12, 13, there will not be any possibility to get 13. Then 14, also no possibility to get 14. 15, no. 16, 17 is prime number. 18, there is 18. And then 20, 21, 22, we have to check one by one. Then is 3 to the 6, 6 to the 12, 12 to the 24, 24, and then 3 to the 6, 6 to the 12, 12 to the 14, sorry 24, 24 3 is a 72, 18, 36, 36 also there is 36. So 36 and then 72. So if the question was like that, how many factors of 72, then we can say that 1 2 3 4 5 6 7 8 9 10 11. 11 factors of 72. 2 1 2 4 6 8 9 12 18 24 36 72. So there will be 3 1 2, there is also there is 3, so we have to 3 is also the factor of 72. Here directly we got 3, so 3 will also be the factor of 72. So this number are the factors of 72. So next question is 84. Again we will go through the factorization method. To this 84 is also the even numbers. 2 4 is 8, 2 2 is 4, 2 2 is 4, 2 1 is 2, 3 7 is 21. We have to go one by one in sequence wise from smaller number to the greater number. From smaller number to the greatest number. So 7 1 is 7. So the factors will be 2 1 2 3, 2 2 is 4, 7, 3 2 is 6, 6 2 is 12, 7 2 is 14. Then there is 21, 7 3 is 21, 21 2 is 3 2 is 6, 6 2 is 12. There is 12, 7 2 is 14, 7 3 is 21, 7 6 is 28. No, 7 6 7 6 is 42, 21 42 and 84. So let me check. 7 3 is 21, 2 2 is 4, 4 7 is 28. So I left 28. 28 we have to check like this method, and the remaining 3 4 sorry, I have done up to 3. Then 4 5 6 7 8 and 9 are homework. If there is any problem, then to comment, I will make another video on that. So the next question is number 2. Find the factor of 135. 135. So 135 5, this number will not divisible by 2, as because this is not an even number. So if we divide this number by 2, it will not be divisible by 2, as this is not even number. Then we will go check for 3, 5 6 7 8 9. So the divisibility rule 3 said if the addition of the number is divisible by 3, then the whole number is divisible by 3. Then we can say that this number is divisible by 3. 3 4 is 12, 3 5 is 15. Again 3 1 is 3, 3 5 is 15, 3 5 is 15, 5 1 is 5. So from here we can say that factors of 135 are 3 1 3, then 5, then 3 3 is 9, then 5 3 is 15, then 3 3 is 9, 9 3 is 27, and then there are 45 and 135. So these are the factors of 135. And in next question, that is 3 1, the question is 135 has dash factors. So in previous question we got that 1 3 5 9. So from here you can say that how many factors are there, and if there is actually from rule we have to again find out this. So if we find out this like that, then we will get these numbers, isn't it? So here the numbers are 1 2 3 4 5 6 7 8. So we got 8 factors. So the answer is 8. In the next number is 3, that is 32. The biggest two digit prime number is, the biggest two digit prime number is, if we the biggest number two digit number is 99. So 99 is not a prime number, as prime numbers means the number which is not divisible by any other number, or the numbers which have only two factors, one in itself. So 99 is divisible by 3, and 99 is divisible also 9 and also 11. So we cannot consider it as prime number. Then we go to 97. The question is the biggest two digit prime number. So this one is the biggest two digit number. This number will not be the prime number. Then we go to 98. 98 is an even number. That means it will be divisible by 2. Then we go to the 97. Then check it, is it divisible by any other numbers? If we go to divisibility rule 2, then it will not divisible by 2. Then 3 9 7 16, then it's not divisible by 3, then also not 4. Then this number is the two digit greatest prime number. So next question is 3. 40 can be written as a product of prime number as. 40 can be written as the product of prime numbers as. So we have to write 40 as the product of prime numbers. So if we go to the factorization method, then we get 220 40 210 2 5s. So 2 is a prime number, 2 is also a prime number, 2 is a prime number, 2 is a 5 is a prime number, is a prime number. So the question was 40 can be written as a product of prime number as. So we can say that it can be written as 2 into 2 into 2 into 5. These four numbers are actually prime numbers, isn't it? The next question is, the next question is 40 can dash is a prime number has dash factors. So we also know from the definition that prime numbers have only two factors, that is 1 in itself. So here the blank should be filled by two factors, isn't it? A prime number has dash factors. We know that a prime number has only two factors, 1 in itself. And the next question is, dash is the only prime number which is an even number. So prime numbers start from 2, 3, 5, 7, 11. These are prime numbers, isn't it? These are the prime numbers. So smallest, actually not smallest, this 2 is the only prime number which is an even number, as because 2 have only two factors. According to prime numbers definition, the number is prime numbers if it has only two factors, 1 and itself. So here 2 have only two factors, 1 and itself. If we divide 2 by 2 1 is 2, so only two factors, that means it has two factors, 1 and itself, and also it is an even number. So 2 is the only even numbers which have only two factors. Next question is 4. What are the 5 multiples of 45? So this is very easy question. 5 multiples of 45. 5 multiples of 45. So first we have to multiply 45 into 5, then we will get 45. Then 45 into 2, then we will get 4 to the 10, 490. Then 45 into 3, 5 3 is 15, 1 4 3 is 12, or 113, 135. Then 45 into 4 equal to 180. 45 into 5, then 5 5 is 15, or 5 2, 5 5 4 is 20 to 25, 15 or 5 and 5 to 25. So these are this 45 90, 45 90, 135, 180 to 25. These numbers are the multiples, 5 multiples of 45. The next question is, write down the 5 write down separately. The question is, write down separately the prime and composite number less than 20. So prime numbers and composite number less than 20. So less than 20, that means the number should be less than 20. So prime numbers start from 2, 2, 3, 5, 7, 11, 13, 17 and 19. These are the prime numbers of prime numbers up to 20. So we know that prime number is the number which is not divisible by any other numbers, or the numbers which have only two factors, 1 and itself. We can say that 2 ones are 2, only two factors, 2 and 1. 3 ones are 3, that means only two factors, 3 and 1. 5 ones are 5, that means only two factors, 5 and 1. 7 ones are 7, that means two factors, 7 into 1. 11 ones are even, that means only two factors. These numbers also have only two factors, that means these are prime numbers. Next one is composite numbers. So from definition we know that composite numbers which have at least more than two factors, that or the numbers which have more than two factors, or the number which are divisible by any other numbers, is considered as composite numbers. So if you go to 2, then 2 only two factors, then it will not be the composite number. Then 3 no, then we'll go to 4, then 2 to the 4, it will be the composite number. Then 5 no, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18. These numbers will be the composite number. As to have we can say that 2 to the 4, 2 3 is 6, 2 4 is 8, 3 3 is 9, 2 5 is 10. That means this number have more than two factors, but this number have only two factors, 1 and itself. We can only say that 2 ones are 2, but in the case of 4 we can say that 2 into 2 equal to 4, and also 2 into 1 4 into 1 equal to 4. So these are composite. In the case of 6 we can say that 2 into 3 equal to 6, also 6 into 1 equal to also 6. So these are the composite numbers and these are the prime numbers. And according to question, up to, less than 20 is up to 18. So the next question is number 6. Express each of the following as the sum of the odd prime numbers. The question is, express each of the following numbers as the sum of two prime numbers. So we have to find out the numbers. The result will be the sum of two prime numbers. So the question is 36. So here the question is 36. No, the question is 54. So the question is 54. So the number should be in the both the numbers, the product of the numbers should be prime numbers, isn't it? The questions according to the question, express each of the following number as the sum of the odd prime numbers. The number should be odd prime numbers. So there the is 4 and 5. So last digit is 4. That means the right digit should be the addition of the right digit should be 4, isn't it? So if you consider here 2 and 2 ending digit, then this number will be even numbers. So according to the question, the digit the number should be in prime number. So we considered 3 and 1. If we consider 3 and 1 in ending digit, then we will get 4. And after that we have to this digit the addition of these two digits should be 5. So if we put here 4, if we put here 3, you have to find out 5. That means addition of 2 and 3, 2 plus 3 equal to 5, isn't it? 2 plus 3 equal to 5. But if we put here 2, then we will get 3 7s are 21. And if we put here 2 plus 3 equal to 5. So if we put here 4, then 43 will be divisible. 43 will be divisible by another number. So the number should be in prime number. So if we put 2 plus 3 equal to 5. So if we put here 2 and here 3, then we will get the product 3 plus 1, 4, and 3 plus 2 5. The number is 31 and 25. And then go to the next 28. So there also the product should be prime numbers. 28. So if we put here 4 and then also 4, then it will the number will not be the prime number. So if we consider 7, and 1, then we will get 8. And next we have to get 2. So to get 2, if we put 1 and 1, then we will get 28. So the numbers are 11 and 17. So the next question is 6 3. The number is 102. So to find out the product of two prime numbers, the number should be the result should be 102, and the product should be odd prime numbers. So here is 2, that means we have to consider two prime numbers in right side, then we will get this result. And to get 10, if we consider 7 plus 3, then we will get these numbers. So if we consider 6 plus 3, yes, if we put here 7, also the number will be the same. So we can put 3 here or here, there will be no any problem. So 71 plus 31, you will get 102. So 71 is a odd prime number, and this, according to the question, the number should be odd prime number. So this number are odd prime numbers. In previous question you also got 54 and 28. So here to get 54, we have to choose any two prime numbers on right side, then add another two numbers, then we will get this. Method is not too tough. Actually you can do this. The next question is 7. Express each of the following numbers as the sum of twin prime numbers. So twin prime numbers, the numbers in between the prime numbers, if there is only one number, then these numbers are considered as twin prime numbers, like 5 and 7. 5 and 7 are two prime numbers, as there is one gap. So this is the definition of twin prime numbers. So the question is, express each of the following numbers as the sum of twin prime numbers. So the question is 36. So 17 and 19, yes, you will get 17 and 19. 17 is also a prime number, 19 is also the sum of these two number is 36. So the number are 17 and 19. The next is 84. So 84 twin prime numbers. So the number should be this number is 4. So if we the right digit should be 3 and 1, and then there is 8. 7, no, if we put here 7 and then 7, then this number will not be the twin prime numbers. So the number should be only one gap. So if we put here 4 and also 4, then we will get 8, isn't it? There is only one gap. In this method we also find out 36 like that. To get actually 36 is a very small number, and we know we have to know up to 50 the consecutive how many consecutive numbers are there. So you can easily find out this 36. And if you go to 84 and in bigger number, greater number, then you can find out like this. The next question is 144. So in 144 also, the right number is 4, that means 3 and 1. The right digit is 3 and 1. Then we have to get get 14. So if we put here 7 and 7, then we also get this, isn't it? Yes, 7 7. So go to the next number 8. Is there any counting numbers having no factors whole? No, there is no any numbers which have no factors. Actually not. One is also a number. One is neither a prime number nor a composite number, but it have also two factors, one and itself. So there is no any number which have no factor. So the answer is no. So go to the next number 9. Write 7 consecutive numbers which are all composite numbers. 7 consecutive numbers. So if we deal with the numbers from 1 to 100, then we will get some numbers which are how many numbers are even numbers, how many numbers are composite numbers, and how many numbers are prime numbers, and how many composite twin prime numbers, like that you will get. So only there are some numbers which are 7 consecutive numbers which all are composite numbers. So if you go from 90, then we will get 92, 91, 92, 93, 94, 95, 96. Then you will get these all numbers are composite numbers. Even if we got from 80 to 86, then you will not get like that numbers. Composite numbers means this number have more than two factors, or these numbers are divisible by any numbers. You can get from 90 to 45 is a 90, you will get, and 91, 730 is a 91, like that you will get. These numbers are divisible by any other numbers, or these numbers have more than two factors. So these are composite numbers. Then go to the number 10. Give 5 pairs of prime numbers in which the difference between the uh, give 5 pairs of prime numbers in which the difference between the number is each pair is 2. So the question is, give 5 pairs of prime numbers. The number should be prime and which have only one difference in between them. So we know we get from 3 to 5, 3, 5, 5, 7, 9. No, 9 will not be prime number. That means 9 is divisible by 3. Then go to 11, 13. Then 17, 19, and 29 and 31. These numbers are the numbers which have only in between them only one number. Then these are 5 pairs consecutive 5 pairs of numbers, and these numbers are also twin prime numbers. So then go to the question 11. Express 77 as the sum of 3 odd prime numbers. So if we write 77, the question is express 77 as the sum of 3 odd prime numbers. 3 odd prime numbers, sum of 3 odd prime numbers. So if 7 11 is 77. So if we add 11 7 prime numbers, then the right number should be 7, isn't it? The the addition of 3 numbers should be 7. So if we consider like 3, 3 and 1, the number will be in between 1 to 10. The prime number is 3, and then 2, 3, and then 5. If we consider here 5, 5, and then the number 5, and then here 1, 6, 1, 7. So this number will be the addition will not be 77. So if we consider 3 plus 3 plus 1, and then if we put here 1, 1, and 1, so the addition of these numbers number is 77. 11 plus 13 plus 1, 1, 5. If we put here 5, 5 plus 1, 6 plus 1, 7. That means we got 77. Again clear it. 77. So the number is 77. That means the product of three number is 7. If we put here 5, then 1, 6, 1, 7, and then is 7. If we put here 5, then this number will not be the prime numbers, as 55 is divisible by 5. So if we put here like 3 is a odd number and also a prime number, and here 3 and here 1. Then we'll get 3 plus 3 6 plus 1 7, and there is the number is 7. So if we put here like 5 plus 1 6 plus 1 7, so this number will be the addition of express 77 is the sum of the 3 odd prime numbers. So these are the 3 odd prime numbers. So the numbers are 11 plus 13 plus 53. So here the chapter is completed. Thank you.